Hey guys, welcome back to another A-level maths revision video. Today we're taking a look at some mechanics and we're going to take a look at calculus in kinematics. So this is pretty much the last chapter of the year 2 applied book. So we're going to take a look at differentiating and integrating velocity, acceleration and displacement, okay, or position. So let's just take a look at the questions. We're going to start off with one exam question from the old exam board. So that was from the old exam spec for Edexcel, so M2. And then we're going to take a look at some questions from the textbook. So let's jump straight into this. So this question's from June 2007 for M2 here. So let's get the right pen colour. Let's have a look at this question. So we're given a particle P of mass 0.5 kilograms. It moves under the action of a single force, and then at time t seconds the velocity is given here. So that's V is equal to 3t squared I plus bracket 1 minus 4tj. So the question asks us to work out the acceleration of P at time t seconds. So how would we do that? Well, remember when you've got, say here, velocity, and we want the acceleration, the way we get from the velocity to the acceleration is by differentiating. So I know some teachers do write it like this, so S, B and T. So when you're going down, oh sorry, that should be an A. I think I might be dyslexic. S, V and A. We're going down, like so. And then going backwards here, so that's differentiating. And then going up here, we integrate. Okay. Like so. So, because we're going down from velocity to acceleration, we need to differentiate. So, the differential here, so dv by dt, that gives us a. Okay, so if we differentiate this now, we get a. So what would that be? Well, differentiating here with respect to t, 3t squared, that just gives us 6t. Okay, but don't forget your I here. Keep that with us, 6ti. So we're differentiating this whole bracket now. Differential of 1 is just going to be 0. And then the minus 4t here would just be minus 4. And we've got the j here, so this is minus 4j. So that's the differential here. And that just gives us our actual answer there for the acceleration of p at time t seconds, because that's the acceleration. And then at time t seconds, we'd just be replacing t with t. Okay, so we don't need to do anything further with that. That's all we need for part A. Part B, there's a little bit more work involved here, because what we're looking for now is the magnitude of f when t is equal to 2. Okay, so how do we get f? Well, remember our laws, Newton's laws, f is equal to ma. Okay, well, force is equal to mass times acceleration. We have the mass, 0.5 kilograms, and we have the acceleration, that's what we've just worked out. So we can put all that together now to work out f. So what I'm going to do first is I'm going to work out the acceleration when t is 2. So when t is 2, what do we get for the acceleration? So 6 times 2, so that's 12. So that gives me 12i. And this would just be minus 4j still. Okay, so a when t is 2 is t is 2 gives us this expression here. Okay, so we have the acceleration, we have the mass, so we can now start putting this together. So f is equal to ma, where m is 0.5. We're told the particle P has mass 0.5 kilograms. So that's 0.5 here times 12i minus 4j. Okay, because that's our A. So m 0.5, A is this expression here. Obviously, just divide everything in this bracket by 2, so that's going to be 6i minus 2j. And now what we need to do is work out the magnitude of this, because this is the value of f when t is equal to 2. So now we just need to work out the magnitude of that. So therefore, do it up here, therefore the magnitude of f, well, we just need to work out the magnitude of this now. That's the same as doing 6 squared. This would be plus minus 2 squared, but it's just the same as doing plus 2 squared. that'll give us root 36 plus 4 here. 2 squared is 4, so that gives us root 40 here. And then you can rewrite this root 40. I'd do it, it's nice and easy. So that'd be root 4 and root 10, and then we can simplify that to bit 2 root 10. Okay, and then don't forget units, because we're working here with a force. Our units will be newtons, so capital N here. Okay, 2 root 10 n. Moving on to our first question now from the textbook. This is from exercise 8D question 4, and we're starting with the position vector here, r. So let's just get the right pen colour. Oops, that's not the right one. Not off to a good start. Okay, so r is 4t squared I plus 24 t minus 3t squared j. So we want the speed of p when t is equal to 2. However, we're starting with the position vector. So remember again, S, V and A. We're going to go down here now, so going downwards. If we're starting with S, or R in this case, and we want V, we know, remember, over on the left hand side, we differentiate, okay? So differentiating here, this expression now, what we can obtain is that V is equal to dr by dt. So that'd be differentiating this here with respect to t, and if we do that, pretty standard, 4t squared, differentiate this, we just get 8ti. Differentiate this here in the bracket, 24t, that'll just give us 24, and then minus 3t squared, if you differentiate that, we get minus 6tj. Okay, so hopefully, so far, pretty standard. Now we have v, so what we need to consider now is what the velocity is when t is 2. So when t is 2, what do we get? 8 times 2, I, so that's 16i. 16i plus, and then do the bracket, 24 minus 6 times 2. So 6 times 2 is 12, and then 24 minus 12 just give us 12. Okay, so 16i plus 12j, that's our velocity here. But remember, we're looking for the speed of p. So how do we go from the velocity to the speed? Well, we just take the magnitude of the square. So, for example, that'd be v squared like that, the magnitude of it. So how do we work out that? Well, just taking squaring both of these here and then taking the square root. So really I could just write that all in one step here as just being 16 squared plus 12 squared, which would give us, that comes to 400 here, square root of 400, which if you put it on your calculator, you get a nice answer for this, we get 20. Okay, now we're working with velocity, speed, so our answer will be meters per second. Okay, so the speed of p when t is equal to is 20 meters per second. Okay, so that's part A done. Now let's have a look, go at part B. So if I clear all this, just so we've got enough room, it's pretty standard again. So we need the acceleration this time. So we started with s, we differentiate to get v, and then we need to repeat that process. We're going to differentiate v to get a. Okay, so a in this case is equal to dv by dt. So what was v? So I had it written down, so that was v is equal to 80i plus bracket 24 minus 6t j. Okay, so all we've got to do now is differentiate this. So if you differentiate this, differential of 8t is just 8, so that's 8i, and then differential of this bracket here, the 24 will just go to 0, and then differential of minus 6t will just be minus 6. So what I get is just 8i minus 6j. Well, the question asks us to show that the acceleration of p is a constant and find the magnitude of this acceleration. Well, the first thing I can note here about my acceleration is that there's no t's involved with this. So the acceleration has to be constant in that case because it's not dependent on time. So therefore, acceleration is constant, bracket, not dependent on time. Okay, so there's no t's in the actual acceleration, so it's constant. So where do we go from here now? Well, we just want to work out the magnitude of this. So magnitude of the acceleration, remember that's just taking the square root of this squared plus this squared. So 8 squared plus minus 6 squared. Or you could just write 6 squared here. So what will this give us? That'll be 64 plus 36. So that's the square root of 100. And then hopefully everyone knows this. Nice and easy. Square root of 100 is just 10. Cover with your units here. So we've been acceleration. This is meters per second, or ms to the minus 2. Okay. So that's that question done there. So remember, when you're going downwards, we're differentiating. Okay. And then when you're going up, we're integrating. So the next question takes a look now where we're going the other way. We're going up. So let's take a look at this one. So we've got a particle here, p, which starts from rest at a fixed origin O. So the acceleration of p at time t seconds is given here. So a is 6t squared I plus 8 minus 4t cubed j. So the first part, very, very similar to what we've just done. That's just to work out the velocity of p when t is equal to 2. So it's pretty much identical, except we don't need to actually work out the last bit, the magnitude. So, and obviously the actual method of differentiating and integrating is different, because for this one, we're going to integrate. So we're starting with a, so remember it's s, v, and a. We just want the velocity. So we're going from a to v, so we're going up, and when we go up, we integrate. So integrating this expression here, so add 1 to the power divided by the new power. So that'd be 6t cubed divided by 3. So what that will actually give us here for v is 2t cubed plus, so that 8 there would be 8t. So that'd be plus 8t. Sorry, don't forget your I there as well. Plus 8t minus t to the 4. Because we add 1 to the power divided by the new power, that's minus t to the 4 j. So now we've got this expression here. The only thing we're missing here is my plus c. And this is important because we're integrating, but we don't have any limits. So what I've actually done is the integral here of 6t squared I plus 8 minus 4t to the 3j. So it's probably important that I write this here, just to emphasise that we have no limits on the integral. And for that reason, we need our constant of integration. So what do we do with this constant of integration? Well, we use some information in the question. And that information comes from the very first line, where it says the particle p starts from rest. Okay, so if it starts from rest, what that means is when t is 0, the velocity is 0. Okay, so what I'm going to do here is sub in. So when t is 0, what do we get? Well, this is very common. When t is 0, what you'll actually obtain is that the actual expression is 0. Okay, so it's equal to 0 on this side. 2 lots of 0 cubed, 0, 8t, so when t is 0, 0, minus 0 to the 4. Everything is just 0. So what we actually get here is that c is equal to 0 as well. And if c is equal to 0, we're just technically dropping it. Okay, so what our actual velocity is just this expression here. Okay, so without the plus c. So what we need to consider now is just when t is 2. So all I've got to do is sub t equals 2 into my velocity here. So v is equal to 2 lots of 2 cubed I plus 8 times 2, which is 16, minus 2 to the 4, which is 16. Okay, well, what will that give us? That'll be 16 here, because that's 2 times 8, so that's 16i. And that's 16 minus 16, so that just cancels. So all we get left with here is v equals 16i ms to the minus 1 there. Okay, so that's just my velocity. And then part B asks us to work out the position vector of p when t is equal to 4. So how do we go about this again? Well, same principle. We're now going from v, the velocity, to s. We want to know the position vector of p. And all we'll do then is sub in t equals 4. So if we're going backwards again, we need to integrate. So s here, so if I just write this down again fresh, so s is going to be equal to the integral of v, like so. So now we need to integrate v, and remember, right angle, this is the integral of 2t cubed I plus 8t minus t to the 4 here, j, with respect to t. So integrating this here, s is going to be equal, so add 1 to the power divided by the new power. So what I'll get is t to the 4 divided by 2, that's I still, plus add 1 to the power divided by the new power, so that'll give me 4t squared, like so. This minus t to the 4, I'll again add 1 to the power divided by the new power, so the integration is pretty standard. That's minus t to the 5 over 5. So I'll put a bracket around this, because this is my j component. And again, we're integrating with no limits, so we need to take into account a constant of integration. But be very careful, just for the case of being a little bit pedantic. We should use a new variable here, so if I call it plus d. And again, let's consider what happens when t is 0. So usually the base case of t equals 0 is the easiest to consider. Given that we're told the particle's at rest, so when t is equal to 0, what would happen here? Well, the speed would be equal to 0. That would be 0, so 0 to the 4 over 2, is clearly 0. And then because both these terms have 0 in, they'll come to 0. So what we get again is that d is equal to 0. So all I actually need to do here now is just sub in my t equals 4. So therefore, t equals 4 gives s equals, so that's 4 to the 4 over 2. So what I'm going to do is I'm just going to write everything in full, and then we'll write the answer down. 4 to the 4 over 2 plus times 4 squared, so 4 times 4 squared minus 4 to the 5 over 5. So you will need your calculator for this one. It's a bit of a messy answer without it, so don't forget your i's and your j's. I'm very bad for that, that's quite a bad habit I have. Plug all this on your calculator though now, and what you'll get here is 128i minus 140.8j. Okay, so that there, this result here, that's the position vector when t is equal to 4 there. Okay. Okay, so moving on to the very last question here. I keep getting disrupted, so it's quite a disjointed recording. But for this last question here, similar principles to what we've just done. Again, it's just assessing whether you know whether we're going to differentiate or whether we're going to integrate. So it's a very important skill, and again, make sure you're aware how to do it. So if we start with r in this case, the position vector, I call it s, v, and a. So remember, that's the order, s, v, a. We start with the position vector. We want the velocity. So that means we're going from s to v. So we'll go from s to v. That means we need to differentiate here, okay, with respect to t time. So doing that with ours, that would be dr by dt. So this is v here. V is equal to the differential of the position vector. Again, just differentiate your trig functions here. So 2 cos 3ti, that would give us minus 6 sine 3ti. Differentiate minus 2 sine 3t, that gives us minus 6 cos 3tj. Okay. So that's velocity there. Now what we want is the velocity of p when t is pi over 6. So when t is pi over 6. So what do we get? Well, think about it. If you do 3 times pi over 6 that cancels there with this to give us pi over 2. Okay, so what they're essentially doing here is just substituting or putting in minus 6 sine, so this is v, minus 6 sine pi over 2, like that. Same again here, minus 6 cos pi over 2. And I keep doing it, don't forget your I and your j component there. Okay, plug these in on your calculator, unless you know them by off the top of your memory, top of your head. That gives minus 6i here, and then this would just come to 0. So our final answer for v is minus 6i meters per second there. Okay, so that's v. We now need to consider for part b the magnitude of the acceleration. So we're showing that it's constant basically. So we need the acceleration. So we're starting with v here for this part b. We need acceleration. So again, we're going down, so we're differentiating again. So part b here, let's try and do it at the bottom. We need to differentiate again. So a is equal to dv by dt. So what would that give us? Well, what I'm going to do here, I'm going to put my j at the front, because if you differentiate this one here, this will come out as positive. Okay, well, that would give us 18 sine 18 sine 3ti. So forget your pi's, we don't need them for this one. 18 sine 3ti. Differentiate sine, 6 sine minus 6 sine 3ti up here. Differentiate that, that'll give us minus 18 cos 3ti, like so. And at this stage here now, all you need to do is work out the magnitude. So the magnitude is the same as taking the square root of your terms squared. Okay, so that would be 18 sine 3t squared. Do the same with this one here. Like so there. Okay, now I'm going to do a bit of a trick here to make life much easier. And the trick I'm going to kind of consider here is using a trig identity, and hopefully it's maybe jumping out at you. The trig identity I'm going to be using here is sine squared x plus cos squared x being identical to 1 here. And how is that going to help us? Well, I can actually split this up here. So imagine you square both of these, you end up with 18 squared minus 18 squared. So both of them would have an 18 squared in. So what I can do is I can pull that out, I can factor that out, right? So what that's going to give me here is 18 squared. And what I'm also going to obtain here is this cos 3t expression squared. I'm going to end up with sine 3t squared, which it gives us the identity that we need. So I can use that now. So what that gives me is 18 squared bracket cos squared 3t plus sine squared 3t. And we can make the use of the fact that this part of the expression here is equal to 1. Okay, but don't forget we're squaring this full expression, just like we're doing here. So what we actually just end up with is 18 squared times 1, so the square root of 18 squared. And hopefully that's nice and easy to see. So doing it over here at the top, what I end up with is the magnitude of a is equal to the square root of 18 squared, which just gives us 18. So because we just end up with a constant here, so this is meters per second, so therefore acceleration is constant because it doesn't depend on time in that sense, it's just a constant. So therefore acceleration is constant, and that wraps up the 9 marks for this question. So I hope that's helped, guys. I made an unbelievable amount of mistakes for this video, so don't do that in your exams, learn from my mistakes. But I hope it's helped. Any comments, any topics you'd like me to go through, please let me know down below.